In this video, you'll be introduced to what's called compound interest. So far, we've talked about simple interest only. And in simple interest, we take a principal or an investment and we apply the interest rate to that one investment one time in a year. This time, we're going to take an investment, compound it, or apply the interest over a number of periods within a year, and we'll always add that interest back to the principal and compound that new amount. So for this particular type of interest, we have a new formula. And this formula is called the compound interest formula. And it looks like this. A, which again is the ending balance or the future value of the money, will be equal to the principal P times 1 plus the rate R over this new variable called N, which is the number of compounds per year. All of that will be raised to the number of compounds N times T, time in years again. So this particular formula introduces us to this idea of compounding over a number of periods. And this part of the equation, R over N, is what we're going to call our periodic rate, which you may see referred to as I. So I is equal to the rate divided by the number of compounds. Now, let's look at an example. This says, find the amount of an investment of $1,000 invested at 8% if the investment is compounded. And we have these different compounding periods. So when we start to deal with compound, the first we need to do these different compounding periods, what we call our N's. And here my N, when you compound annually, that means you do it one time a year, N is equal to 1. The next one, semi-annually, means I do it twice a year, so N is equal to 2. Quarterly means I do it 4 times a year. And monthly means I do it 12 times a year. So the N is telling you how many times you're going to look at this equation or its compound interest formula and add it back to the principal to get your new ending balance. So let's do annually first. When we annually compound the formula again, finding the ending balance, A is equal to, well, the P here is $1,000, so much you're investing. Your R is this rate. That's the rate expressed as a decimal. So our R for all of these problems will be 0.08. And then our time is, we'll assume, since there's no time given, we'll assume they're talking about 1 year. So let's let T be 1 for this particular problem. So in this first one, we'll plug in P. So A is equal to 1,000 times 1 plus our R, 0.08, divided by our N for the first one. So this is A we're doing first. And that'll be equal to 0.08 over 1 times NT. Let's actually make T be 3 years. So we actually have a number to work with there. So let's assume that the time here is 3 years. And again, no time is given to me, but I'm going to make it be 3 because that's what I want to work with right now. So let's assume the time is in 3 years. So we would have N, which is 1, times our T, which is now 3. We changed it to 3 years. And so when I calculate this, in a calculator, remember, when you deal with these things, you need to carry answers. So we're going to do this part of the equation first. And we'll actually work 0.08 divided by 1, which is just 0.08. And it will add 1 to that, so we'll get 1.08. So we have this now. A equals 1,000 times 1.08. And then we can multiply this right here, 1 times 3, which is just 3. And then we'll do 1.08 raised to the third power in our calculator. So I get A is equal to 1,000 times My calculator shows 1.259712. That's what my calculator shows. It's actually further than that, but since this is what my calculator shows, I'm going to leave it in my calculator and just multiply this number by 1,000. And I'm going to round that final answer to cents. So when I round this final answer to cents, I get $1,259.71. Now, for the other problems, they work the exact same way. The only thing that's going to change in each one of these problems is going to be the n. So I'll do B next. Let's look at it when we do it twice a year. We compound twice a year or semi-annually. So A is equal to 1,000 times 1 plus, still 0.08 is the rate, but now my n changes to 2. And instead of doing in a year, instead of doing one compound like I did in the first one, I'm doing 2 compounds. So I multiply that by 3 years and I get 2 times 3. And when I calculate this in my calculator, again, this time I'm going to do 0.08 divided by 2 first. And I get 0.04. I'm going to add that to 1. And I get 1.04. Then I'll raise that to the 2 times 3 power, which is the 6 power. And I get 1.265319018. So my calculator say, I'm going to keep that answer in my calculator and multiply by 1,000. And here's my final answer. 1265. So $1,365.32. If we do C, same process, except A is equal to 1,000 times 1 plus, again, 0.08. But this time I'm compounding quarterly, so I'll divide by 4. And that means I'm going to have 4 compounds in a year, so I have 3 years, so that's 4 times 3, which is 12. And so again, I'll start with the inside first. 0.08 divided by 4. It's 0.02. Plus 1 is 1.02. I'm going to raise that to the 4 times 3, which is 12. So 1.02 raised to the 12. I get that number, 1.268241795. Leave that number exact, multiply by 1,000. And I get $1,268.24. And if you notice, look what's happening to your actual value. When we did it one time a year, we got $1,259.71. It increased when we did it twice. It increased when we did it 4. It will increase when we do it 12 as well. As a matter of fact, when we do it for the monthly compounds, I want you to notice that when we do monthly, A is still equal to 1,000 times 1 plus 0.08 divided by 12 raised to the number of compounds, which is 12, times the number of years, which is 3. The thing I want you to look at is this 0.08 divided by 12, which again, that's going to be referred to, you may see it referred to as I, which is called the periodic compound. Your periodic compound is decreasing, actually. This number inside of here is getting very small, but you're raising it to a higher power. So that's why your money is growing, but it's not growing a whole lot. So as a matter of fact, when you do it at this amount, if you do 0.08 divided by 12, you get 0.00667. Add that to 1.00667. Leave that answer in your calculator like it is. Raise that to the 12 times 3, which is 36. I get 1.270. Leave that number as it is in your calculator and multiply it by 1,000. And I get this amount right here. A is equal to $1,270.24. So notice your money grew, but it didn't grow as much as you would think it would. And that's because this periodic rate is a lot smaller as you're increasing the number of compounds.